Hello friends, so in today's video we'll do the application of limit comparison test and the p-test and how these two tests are made for each other. Now we'll do the application of this. Now first we'll discuss what is positive term series. Positive term series. An infinite series, that is summation un, n varies from 1 to infinity, is said to be a positive term series if un is greater than or equal to 0 for all n belongs to the natural number. It means all the terms has to be positive. Now, number one thing that you should be keep in your mind, a positive term series either converge or diverge. It never oscillate. Now, there is another criteria, that is necessary condition for convergence. What exactly is this saying? That if summation un is a convergent series, then limit n tends to infinity of un is 0. Student, it is a necessary criteria, because if you came to know that the series is convergent, then the limit of nth term is 0. But it is a very good criteria to show something which is not convergent. And that is, if we have, suppose, if a positive term series limit of nth term, that is un upon, is not equal to 0, then summation un is divergent. How? I am considering one example. The question is test for the convergence. Test for the convergence. Summation n upon n plus 1, n varies from 1 to infinity. Now what you will observe here, student, your nth term is n upon n plus 1. Now if I take the limit of nth term of un, either you can apply L'Hopital rule, or is a very simple, you take n common from the denominator. Now see, this limit is 1, which is not equal to 0. Hence, the given series divergent. Now we have another test, that is what we call limit comparison test. Limit comparison test. In short, we call this as LCT. And please mind it, we will use this for only positive term series. So we are assuming, let summation un and summation vn be the positive term series. Now what this test is saying, that if limit n tends to infinity, the ratio of their nth terms limit is some L, and if L is finite and non-zero, then summation un and summation vn behaves alike. Now student will explain it, but there is one more test that I am going to discuss here, what we call that is p-test. The p-test is something like there is a p series of the form summation 1 upon n to the power p, n varies from 1 to infinity. Now if you came to know that this p is greater than 1, then the series is convergent. If p is less than or equal to 1, then the series is divergent. So we'll make use of both the test while finding the problem's solution. We'll use both the test simultaneously so that we can make use of the convergence or divergence. Now, how this test will come and where we should apply, I'm just telling you the condition. If the nth term of the series, please note down that, if nth term of the series does not involve factorial, that is this, and does not involve increasing power of x, and also does not involve the product of the type, like this, 1 into 3 into some 2n minus 1, then we always prefer LCT, always use LCT, students. So this is the way that you can recognize that where you should apply it. Now I'm going to solve few problems for so that you can understand it. The question is something like that. Number 1, test for the convergence. The series is 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 and so on. Your first task is to get the nth term of it. Now if you see it, in order to write its nth term, now see, 1, 2 and 3, they are forming an AP, or either you can say that these are conjugative terms, n into n plus 1. Please make sure that, student, in a question Vn will not be given. How will get Vn? Taking common highest power of n from the numerator and denominator. So if I take one more n common, I am defining this as my Vn. Now I have defined my Vn as 1 by n square. Now apply LCT. So limit n tends to infinity of un upon Vn, that is equal to something 1 upon n square, 1 plus 1 by n and n square. This will get cancelled. Now what will be the limit of this? 1, which is finite and non-zero, which is finite and non-zero. So therefore by LCT, summation un and summation Vn behaves alike. Now what do you mean by summation behave alike? Now since by p test summation n square, here p is 2 more than 1, is convergent. As their behaviors are alike, so therefore I can say that this will imply summation un is also convergent. So this way, student, you can make use of this, because you can say that this p test and the LCT, they are made for each other in the maximum problems, so you can use it. Now let us solve one more problem so that you can understand the application part of it, that how you are utilizing it. Now see, suppose we have the problem something like that. One more problem I'm solving for you. The question is, test for the convergence summation n square plus n plus 1 upon n raised to power 4 plus 1. Here nth term is already given. So my un is, I have deliberately taken this example. Now how to get Vn? Taking highest power of n common from the numerator. we have taken, and the highest power from the denominator. Now what left? It is turning out to be 1 by n square times of 1 by n square. So what I will do, I will take this as my Vn. So I have taken my Vn as 1 by n square. So now by LCT, limit n tends to infinity, Un by Vn will be equal to limit n tends to infinity. That is simply, you can say that n square by n square, because it will come in the numerator part, upon 1 plus n to the power 4. Now see, if you take the limit of it, which is 1, which is finite and non-zero, so therefore by LCT, summation Un and summation Vn behaves alike. But summation Vn, which is equal to summation n square, here p is a 2 more than 1, so summation Vn is convergent. So this will imply summation Un is convergent. So this way you can get the solution of this type of problem. Now I'm solving one more type of problem so that you can understand it. Suppose the problem is like this. Test for the convergence. One by 5 plus root 2 by 7 plus root 3 by 9 plus root 4 by 11. Now the first task is to write its nth term. Now 5, 7, 9 and 11 making an AP. There is a common difference of 2. So you can say that your Un will be equal to root n upon 5 plus n minus 1 into common difference 2. So we can write this as root n upon, it is nothing but 2n plus 3. Now again from the Un we will get Vn. And in the numerator itself root n is common. In the denominator if I take n as common, so 2 plus 3 by n. Now if I adjust this power, so it is turning out to be 1 by root n times of this. So you can say that my Vn is turning out to be 1 by root n. Now let us find the limit of it, the nth term of this ratios Un by Vn. It is turning out to be root n, and please take the simplified version of it always, because it will help you in the calculation. 2 plus 3 by n. Now see, this root n will get cancelled. Now this limit is nothing but 1 by 2, which is finite and non-zero, which is finite and non-zero. Now see student, what we are going to do here now, by LCT, therefore by LCT, summation Un and summation Vn behaves alike. Therefore summation Vn, which is equal to summation 1 by root n, and p is 1 by 2, which is less than 1, which is divergent. So hence summation Un is divergent. Now I'm going to solve one more problem for you so that you can understand it more clearly, because we have the several way of dealing. You have to just make the practice of it. Only the practice makes you the perfect. There is no other way that you can deal with it. Now suppose the question is test for the convergence summation sine 1 by n. Now see what you will do. We please do remember the series of sin x by x cube by factorial 3, like this. Now what is sin 1 by n? It is 1 by n, 1 by n cube into 3 factorial plus 1 upon n to the power 5 into 5 factorial and so on. So I can take 1 by n as entirely common, and 5 factorial and so on. Now if I take my Vn as 1 by n, now what you will observe, limit n tends to infinity, Un by Vn is nothing but, is simply limit n tends to infinity. I can take directly also sin 1 by n upon 1 by n. Now see, when n tends to infinity, 1 by n tends to 0, so this limit is 1. So which is finite and non-zero. So by LCT, summation Un and summation Vn behaves alike, but summation Vn, which is equal to summation 1 by n, is divergent by p test because p is 1. So therefore summation Un is divergent. So student, it is my advice, so please watch this lecture again and again so that you can understand that how I am applying it. I hope this concept is clear to you. So that's the end of this lecture. I hope you must like this, and please subscribe to the channel